All right, we're here at the 2012 Northeast U.S. Mesh Networking Summit. We're here with Caleb James Delisle, and we're going to talk about CJDNS and some other exciting developments in the sort of infrastructural layer of network routing and management. Remember, the 2012 Northeast U.S. Mesh Networking Summit is sponsored by slashRoot and by Open Mesh. Caleb James Delisle, welcome to slashRoot.
Thank you. Thanks for having me.
The first question that I think is sort of on a lot of people's minds who are taking a look at these issues right now is what is, if you could sum up, what is the critique that you're trying to make with CJDNS? What need does it address, and how does it reflect the changes that you'd like to see happen in network routing on the internet?
Well, a few years back, I tried to figure out how I would build a mesh network of my own that went to the top of the hill, and I live in the middle of nowhere. So I tried to solve these problems where I would have my node, and then somebody else would have another node, and then somebody else, and then eventually it would get back to the internet. And the problems that I ran into were that somebody needs to give out IP addresses, and that works fine when you have just a few IP addresses and a few people, but as it grows, then you start to have this ICANN type organization, and well, they haven't been all that good at delegating IP addresses for the IPv4 section. I mean, Ford still has 16 million of them. Now, could we do this better? And the second problem is that how are you going to protect against a node along that route reading your data or modifying it, doing anything, eating your passwords, whatever? And if we're going to have a mesh network where you may be connected to strangers, then you really have to be able to trust that without trusting them, that you can trust that your data is what you think it is and that it is not being read behind your back.
Why doesn't SSL do that? I mean, we ostensibly have solutions for that today. What?
Well, SSL is a nice idea, and it worked well early on. But what happened was there was a proliferation of the number of certificate authorities. These are organizations who have the power to say, you are google.com, and therefore your key is valid for Google. And we've had various hack-ins to these organizations where people have gotten control of the computer and then made themselves certificates so that they could pretend to be Google. And the problem is that there are so many of them, and one breach makes everybody insecure. I would rather if everybody was secure until everything was breached. And so in CJDNS, one of the key points is that the IP address, the IPv6 address, is the fingerprint of your public key.
Where do you envision name service going? And I guess particularly, what do you think of Namecoin and sort of what do you think of the existing the loudest of the existing critiques of name service?
Well, the problem with name servers is that somebody has to be in control because it's a database. The DNS is a database, and somebody has to say, this is the truth. Now, the problem is that somebody says, I don't like this website, I don't want it to go away, and then they go and they pull strings and they push on the person who is in charge of the truth, and then they make them change it. And now, we're not just talking about government doing this. This has been done by hackers. None other than Anonymous changed a website belonging to the MPAA to publish one of their manifestos.
And you point out in the README of CJDNS that you think that this is has a certain providence rather than coincidence to it, that the sort of same exploit is being used by both sides. I mean, is that how do we move past that kind of dualism?
I think that we need to all get together and to understand that insecurity benefits nobody. There's this thinking that if the government has control of things, then they're secure. And this is a popular and was a popular thinking within government circles. But we're starting to learn that if systems aren't secure on their own, then they will not be secure at all.
And how about Namecoin? I mean, do you think that Namecoin proceeds with that principle in mind?
Namecoin has the security down, but their problem is that they charge money for these names, and then people get the money when they calculate the numbers, and we don't need that. What I would like to see happen is a domain name system where there is a central organization that decides on the names for any given top-level domain, but that central organization doesn't get to then turn around and say, oh, we're revoking this one. Once they've given that domain to those people, then those people get to keep it as long as they maintain it.
Sure. So what you told the story at the beginning here of being up on a hill and kind of visualizing a series of nodes on the way down the hill. How do you see CJDNS playing with the hardware mesh layer that is kind of being discussed in networking circles around the world?
Well, I want to be clear that right now we're doing an experiment. We're in testing mode. So if people want to get together with a few friends and build a mesh network, don't try to use CJDNS right now. Come back in a year. If you want to experiment, if you're a programmer, if you're interested in actually solving problems with routing and with security, then I want you here. I want you in the IRC channel.
And what is the IRC channel and what server is it on?
It's on FNet. It's CJDNS.
So do you see, I guess, is to what extent in the future, in sort of if we move to 1.0 thinking, to what extent is a killer app for CJDNS to continue to operate the sort of entrance nodes from the internet the way that it does?
Where I see this going in the end is we're going to build the modular ISP. And the modular ISP is where you have people running their own nodes and people who get access to the internet, and the internet access people interact with the customers, and then the money flows down along the group of people who provide the nodes. And now money does have to flow because that's what gets the bigger nodes installed, because we want to carry the most bits. We don't want to be the company that makes the most money. We want to be the amorphous group of companies and people that ends up actually carrying the most data.
Does CJDNS occupy the same space either technologically or socially as Tor? And I noticed that you are not hesitant to critique Tor's sort of absence of an abuse policy. How does what's the story here? Is CJDNS going to supplant Tor? And how does a community come up with an abuse policy? What does that look like?
Well, what we're doing now, and this is our test network, which we call Hyperborea. The network is friend to friend, which means you connect to somebody who you know, and they connect to somebody who they know, and they connect to somebody who they know. And then through that, you can connect to everybody because it's a routing network. Now, if you were to serve some web page which is considered horrible by everybody, then the email would go around, people would communicate, and then your friend would say, hey, cut it out, or eventually you'd get turned off. So there is a democratic way of handling abuse, whereas in Tor you just connect to anybody, and that then you serve anything, and nobody really knows nobody knows what they're transferring in CJDNS either. But in Tor, nobody is able to know who they're connected to. Now, the other thing that is different about Tor than CJDNS is that Tor is inherently an overlay network. It needs the internet. It goes to a list of nodes, it picks one, and it connects to it. It asks that node to connect to another one from the list, and it asks that one to connect to another one. And then using a route tunnel, it bounces from one to the other and then comes out the other end.
But the underlying methodology is presumably applicable to an air-gapped deployment or to an intranet.
Tor needs the underlying IPv4 system
right, but that could be replaced, and we'd still have these sort of competing methodologies. I mean, do you think that that's central? Do you think that's central in a use case kind of way to Tor? It seems like that's just the problem they're addressing now.
Central to CJDNS is that every connection is made from one friend to another, and so therefore that one tunnel could be replaced eventually by a fiber link or a wireless link or anything else because it's just one connection. Whereas in Tor, you start it up and you make connections to hundreds of people, hundreds of direct connections to other nodes. So there's this rolling list of connections that are being made and broken, and that really requires an underlying network, and that's what the onion router depends on. Now, that's not to say that onion routing couldn't happen on top of CJDNS, but we're not trying to replace Tor. We're trying to replace the internet.
So that's heavy. So CJDNS you don't think is in the same exact space. It's not an exact horizontal sibling with Tor.
No, and it's closer actually to some of the darknet attempts that have been before. And again, this is just an application. You can take the same software and run it in a mesh. You can run the same just by changing the network module. You can run the software in what we're doing now, which is a darknet. That is a network which is all closed off from the outside. And if you don't have a friend, then you can't get in. I've done an examination of various other networks, GNU-net and AnnoNet and darknet conglomeration, and the problem that they seem to run into was that if they would run for a while and then some people wouldn't keep it up and the software would start to break down, and everybody needed to know a lot of routing technology to be able to make it work. Everybody needed to be a network engineer. And I want to take the network engineering step out of actually running a router, having a router that runs itself.
Well, you say your dream is to run a single binary and have it give you a tunneling interface.
Yes, and we're very close to that right now.
How close?
Well, I'll show you later on when we start it up on a computer.
All right. Let's go back to talking about some of the sort of socio-political critiques inherent in the project. Caleb James Delisle, you seem to note in both the README and the white paper that frivolous litigation is in essence a network problem. How do you think, is that a fair assessment? Do you see frivolous litigation as being in the same sort of space in terms of problems as DDoS or something we think of as more traditionally a network problem?
It is a denial of service attack when you can essentially buy a dime store lawsuit and send these DMCA notices, and anybody in the ISP realm knows about DMCA notices, and they know that a lot of these are just sent by people knowing that they're not valid and that the ISP has to make a judgment call on each one, and that raises the cost of being an ISP. I don't want to facilitate crime, and that's why I have an abuse policy. Well, I don't have an abuse policy, but the network has an abuse policy, defined a democratic abuse policy. But at the same time, I want to make it to raise the bar a little bit for people who just want to send these frivolous notices and cause ISPs grief.
Well, how do we do that? What exactly has to exist in the networking space at the infrastructural level in order to have a sort of robust defense against the denial of service via the courts, as it were?
Well, right now, what we have to, and it gets back to getting your IP address. Most people get their IP address from their internet service provider. Say, I need internet and I need an IP address, and they give them an IP address. Now, the people who do the attacking will go and harass the person who gave you your IP address, saying that it's somehow their fault. Now, those who can get so-called provider-independent IP addresses are in a completely different ballgame, because they can connect to anyone whom they want to, and they can multi-home, and then the only person to go after is them themselves. You can't intimidate their providers into shutting them off.
What are the few core features that a network has to have in order to have robust security against all the sort of various denial of service attacks? I mean, what are those features? What in specific terms, what are we talking about?
Well, we need to be able to get IP addresses a better way, and one way is generate it with a key. I haven't figured out another way. We need to be able to have some measure of privacy when we're connected to the network. There needs to be some kind of effort made before somebody can just say, I'm going to send a DMCA notice to these people because I don't like what they're saying.
Sure. And I guess, so then we're really, to get back to the notion of the abuse policy, we're talking about really a community where the networking infrastructure and the sort of role as ISP and the role as creator of abuse policy and the role of reviewer as DCMA arbiter, or not arbiter, but at least the making the initial judgment, right? These all now start to be part of the same organization, the same community, the same set of individuals. So, what is that? How does that community work? I mean, what do you have an idea of what the vibe of that community has to be? I mean, how do we build these communities? How do we go out into our neighborhoods and kind of establish this way of thinking?
I think the thing to do is look into history when things were distributed and power was distributed over a large group. And we look at organizations like FidoNet and like Usenet. Usenet had a spamming problem, and they actually kicked off some large servers. AOL, for example, was thrown out of Usenet because there was too much spam. So right there is an example of an abuse policy in action. And with no one group, no one court deciding that this is the truth and this is how it shall be.
Speaking of Usenet, I'd like for you to react to, I guess, what's now a relatively famous quote. John Gilmore said that the internet interprets censorship as damage and roots around it. What is your reaction to that? Do you think that is the internet an organism? Does it perform that function? Can that little bit of its metabolism be sort of made more healthy?
Well, if the internet is an organism, it's kind of like a mind, and it sure did get a kick out of April Fool's Day a few years ago. Remember that?
Which one are we talking about?
It seemed that when a meme passes through the internet, like April Fool's Day, something that was huge just a few years ago, and now it's just another day, and the Rickroll, and all these things that come on to the mind of the web. So I would say that yes, it is an organism larger than we are, and we have some kind of responsibility to make sure that it can't be abused and attacked. I don't consider censorship per se to be evil. I consider abuse of censorship in order to destroy the mechanisms by which it should operate.
I think Gilmore was talking about it. He was describing a certain autonomy. At least that's my sense. And I don't know. I don't think anyone, including John Gilmore himself, is exactly sure the moment from which that quote sprang, or maybe he is. But it seems like the notion underlying that quote is something more like the internet does this by virtue of its existence. It's part of how it lives and breathes is to circumvent censorship. Do you think that is so?
Yeah. As far as I can see, you have the Streisand effect, and it's what's baked into all of our minds is that when somebody wants you to not know something, you want to know it. It's curiosity, and you want to make sure that other people who are your peers are able to know it. Because if somebody wants you to not be educated in some way, then that's probably some information that is they're trying to cover up, and that's probably a bad thing.
Caleb James Delisle, what operating system do you use, and have you participated in the packaging of CJDNS and in any of the operating systems where it's packaged in repositories?
I use Debian. What I like to distribute are sources. I want to make the download and compiling of the source a very easy thing to do. I have kind of the Gen 2 mentality that you should just be able to download it and compile it, and that will just work, rather than distributing binaries. A few people have distributed binaries. I can't really speak to them. I guess they work.
So you don't recommend apt-get install CJDNS?
We'll get there, but the other problem with binaries is that if you download the source, then you can just go git pull, and you have the new version and you've built the new version. And with binaries, there is this tendency to let things go too long, and at this stage of the game, you can't let things go too long. Development is going just too fast for that.
So speaking of development, what can people who kind of live in the application space, people who are web application developers or mobile application developers, perhaps the Django community, the Rails community, what can people who are kind of occupying that space do to signify that they are generally in support of your critique?
Well, if you want to help with the software, we need a front end. We need a user interface, and I'm not a front end guy. The engine itself you can talk to it using BENC, which is the B encoding from BitTorrent. So most systems have libraries for that. Most programming languages have libraries for that, and you can make calls against it and put forth a user interface which people can interact with, and which does make it as easy as turn it on and it works.
Well, CJDNS is written entirely in C, is that right?
It's written in C, and it has a bunch of JavaScript in the front end in the what we have of a user interface, and it just serves you a bunch of JavaScript and then hopes that your JavaScript will make RPC calls back to the server, and that will get information out of the router.
And how are application developers going to relate to technologies like CJDNS? Are we going to have a REST API? Are we going to have a lower level library? Are we going to have something that feels like some of the more advanced features of the socket library, but that kind of have some mesh-oriented instincts? I mean, what's the real exchange going to look like between people who are in the infrastructural space and in the application space?
Right now, the way you talk to it is you open a TCP socket and you make calls on it, and it passes you the data back. You can connect to that TCP socket with anything. And just recently, the node connects to its own TCP socket and sends in parts of the configuration, and it will be more of the configuration, so that you can reconfigure it through the same TCP socket. So the administration port is going to be the one way to get information in and out of this router, and that's for a number of reasons, largely security, because we want as little code to be exposed as possible to possible attacks. It's all C,
sure.
So it's all dangerous.
Right, of course. But what is sort of the next step? Are you calling on the development world to make an API? Or do you think a REST API is appropriate? I mean, what is going to have to happen to get application developers thinking seriously about building features that are consistent with the underlying methodology?
I'm a let a million flowers bloom guy. I say, if you have a good idea, if it should be REST, then make a REST connector that connects back to the node and then allows REST calls to come in. Right now I have a very naive HTTP server which you call, that makes calls to the router, and you can call it and get basic web pages with JavaScript in them, and then your JavaScript calls go to the HTTP server, which goes back to the router.
So it's not merely a TCP socket. You do actually have an HTTP interface at this point.
Right, but the HTTP interface connects to the TCP socket.
Of course,
you can connect anything to it. That's what the goal is.
And I mean, I guess are you interested? I guess I'm wondering how far. And this is not just for CJDNS. I'd like to hear your sort of vision in general. How far up the stack does the routing engine reach? I mean, are we going to be? Is there going to come a time when the routing engine is parsing JSON?
I hope not. I'm trying to keep it.
That seems to be popular with Go. You know, I mean, the Go language apparently has a JSON parser built in, and people are talking about building low-level applications that have that are parsing pieces of knowledge that come from further up the stack. Where are the hands going to meet ultimately? When we're at the 1.0 level in terms of deployment of CJDNS and other similar. I mean, we've got to have a meeting place, right? So where's that going to be?
I have made a lot of effort to keep things out of the router because everybody has a different use case and a different need, and if you start including things into it, then it starts getting big, it starts getting buggy, it can't run on tiny equipment, and right now it can run on very small OpenWRT type equipment, and it doesn't serve everybody. And I want to build, if you need something that's higher, then build something that connects back to the router through the interface that it has, and then provides the interface that you want.
So your plan is to have people continue to use B-Ink for the foreseeable future. That's the interface.
Yeah, unless there's something else that can replace it wholesale, and it can be a parser in 300 lines. It's hard to beat that.
Sure. Caleb James Delisle, let's talk a little bit about the white paper and the README for CJDNS. These documents, I think it's safe to say, have been pretty inspirational for a pretty wide community. They've been really caught fire and been read by a huge part of the networking world. When you wrote these documents, what kind of state of mind were you in? What were you trying to accomplish with both the README and the white paper?
Well, the white paper started out as my big code comment, and I just kind of moved it over here so that I'd remember, and then I have something to show people. And then it grew, and then I refactored it, and then it was kind of like the dumping place for how the switch works, and then I ended up documenting the router a little bit.
But it has some socio-political angst, right? I mean, it's obviously reflecting a vision of a different world. Is that fair to say?
Well, I like to think that we as programmers, our job is to create reality. We're creating the future, and that's a huge responsibility. We have to look into the future in everything that we do and decide, what is this going to mean in 10 years and 20 years?
And what is it going to mean, Caleb James Delisle? What is CJDNS going to mean in 10 or 20 years? What reality are you making?
I hope that what we will have is an internet where everybody has a stake in the routing, where a stretch of fiber might belong to somebody as part of they buy it when they buy their house, and that fiber goes 20 miles, and that is how intercity fiber works. And we decrease the large corporations' control over these big pieces of infrastructure, and we move the infrastructure out to the people by making routing easy, and especially in the edge, where the core is there is a lot of intercity bandwidth, and at the edge there's stagnation. Data isn't getting out to the edge fast enough, and that's where people can get involved. We just need to have protocols which are easy to set up.
And so, with that vision in mind, what's next for CJDNS? What tickets are you dealing with right now? What pull requests are you dealing with right now? Or what's on your mind in the very near term?
I like to deal with pull requests because they're code.
Yes.
DNS was originally going to be what it was, but DNS is hard and routing is easy, and routing is easier than DNS, and I kind of had an insight that I could do routing. And
so are you saying that DNS is the next logical step? Is that where we're going?
It's bumped back up the to-do list lately, so we're looking at it. If it's feasible, then we will probably go for it. And other things, there are lots of little bug fixes. We need to handle maximum transfer units correctly. many little things. There's always need to improve the router, and I hope that people out there are thinking about if they study routing protocols and they're interested in a routing protocol that where nobody knows the way to everything, then that they will be interested in getting involved in tuning the router, because I can put things together, but the real tuning and the real mathematical stuff, it gets above my head.
So what specific ask do you have? Talk to the development world right now and explain what you think you need to make CJDNS to get closer to 1.0 and to kind of really make the critique that you're trying to make. What is it that you need to ask of the development community?
The routing protocol works by routing a packet to the node that you know of, whose IPv6 address, internal address, is closest to the target, but their link state and their distance is closest to you. That means that nobody needs to know the way to everything, and yet the packet will end up at a node whose IP address is close to the destination. All nodes have to do is keep track of other nodes in the network whose IP addresses are close to theirs. This is nodes that are not one hop away from them. These are nodes that are far away from them, whose IP address is close to theirs. I need to tune that, and that has turned out to be very difficult to tune compared to OSLR or HSLS or Batman, where it's a basic flood network. You broadcast a packet out, and this turns out to be very difficult to get right. And if people want to take this up and know some C or want to learn some C, then that would be really exciting.
What kinds of hardware do you ultimately want to provide support for? I mean, it seems like CJDNS has a bit of pride about running across a relatively wide spectrum of devices. Not Windows, though, I notice. What kind of hardware are we going to see CJDNS 1.0 running on?
We're expecting to run on everything from the small open WRT little device that plugs into the wall or sits up in a tree, all the way up to, I want to see high-end PCs doing routing packets using graphics processors. That's the gamut. And we can do it because the switch protocol does not require memory lookups, only the routing protocol. The vast majority of packets can be routed without a single memory lookup.
Let's talk about that. I hadn't intended to ask about that, but I noticed that that's featured rather prominently in the README. I mean, what seems like the advantages are obvious, but why don't you delve into it quickly about the switch engine not dipping into memory lookups? How does that work, and why? How does that work? How is that different, and how does that speak to your vision?
Well, with traditional routing, you figure out the path to the node that you want to send a packet to, and then you hand the packet to the next node along that path, and you hope that they get it right too, and that they calculate the same path. And this means that everybody has to look at the packet and then calculate the path that the packet should take. The difference of CJDNS is that you calculate the path and then you put a header on the packet, and the header could almost be considered as turn right, turn left, turn left, turn right, turn right, turn right. It's sort of a directions. And so when it gets to the next node, all they have to do is decode part of the directions, pull that part off, and then send it along its way.
And does that speak to your sort of social commentary about needing the ease of entry into to being an ISP? Is that
absolutely? And it also speaks to the really big ISPs. They're using extremely expensive equipment, $200,000 for a line card, and the line card's job is to send packets from one place to another based on their IP address, and they do that lookup, that calculation of the route in hardware. That's very expensive, very fast hardware, and I think that we can do better.
Caleb James Delisle, you have in the last few months become one of the most noted developers in the world. Where do you is your intention to continue working on CJDNS? Do you have any other projects in the works? Where do you see yourself in a few years, and in what way has your life changed since kind of being a very notable developer?
I'm still me. I've been working on this for a little bit over a year. And I just ran into this MeshNet people who were, all of a sudden, all these people were interested in building this network, and I came and I said, hey, I tried to do that, and I found that there were all these problems, and I've been working on software to solve them. And then it just kind of took off from there.
Well, thank you very much for joining us today, and it's been a pleasure to have you here at the Mesh Networking Summit. I'm sure we'll have some cool hacking to do for the rest of the afternoon, but I really appreciate you answering our questions.
Pleasure to be here. Thanks for having me.